Here we are at our example 7 from our 8.47 notes. We're kind of shifting gears now toward dividing rational expressions. Before we kind of dive into this though, I'd like to actually look at kind of like a parallel type of question. If, for example, we had something like 1/2 and we are dividing by another fraction, we'll say he is 3/4. So we're taking 1/2 and we're dividing by 3/4. From the past, we know that we would have the first one staying exactly the same, that 1/2, and we're going to go ahead and flip the second one. So it actually becomes 4/3, and instead of a division symbol, we change the sign to a multiplication. And then we kind of just simplify things from here, like 2 goes into 4 2 times. So it eventually comes out to be 2/3 for this kind of like side example. Now how that relates with us, with what we're seeing with these rational expressions, is pretty much the exact same thing. What we're going to go ahead and do is you could factor first. Personally, I'm a fan of the factoring first, or you could just go ahead and flip-flop these two. I think for example 8, I'll show the factor one first, but for this one, we'll kind of give you a little piece of everything. So we'll keep this one, this rational, just the way he is, this first rational. And then the bottom is x squared minus 7x plus 10. Now the second one, just like we saw with our analogy, we're going to go ahead and flip him, because we have a rational expression divided by another rational expression. We're going to go ahead and flip these. So that x squared minus 2x minus 15 is now on top. On the bottom, we have that 25x squared minus 9. And instead of a division symbol, we're going to go ahead and change it with a multiplication symbol. Next, what we would go ahead and do is just factor each item appropriately. So looking at this top left one, should come out to be 5x and x. Two things that multiply to 6, accounting for the 5 too, that add to -7. I'm thinking 3 and 2, and I'm thinking 2 is going to go here, and 3 will go here. Because that'll give us 10, this is 3, that should combine to give us that 7 that we're hoping for. Now looking at the signs, we have to have -10, so we're going to make this 2 negative, and this 3 positive. When we factor out this top left piece, we should get 5x plus 3 times x minus 2. On the bottom left, we would have x minus 5 times x minus 2 times, looking at the top right, factors out to be x minus 5 times x plus 3. And on the bottom right, we are looking at the difference of these two perfect squares. And so that should factor out to be 5x plus 3 times 5x minus 3. Now going ahead and canceling out what we can. There's a 5x plus 3 on top. There's 1 on the bottom. We can get away with this move because we are, again, multiplying. Looks like there's an x minus 2 on top and bottom as well. There's an x minus 5 on top and bottom. And that pretty much appears to be everything that can cancel out. So it looks like our final answer then just comes out to be x plus 3 divided by 5x minus 3. Probably indicate that these are all equivalent statements. But again, though, that is our example 7 from our 8.4 set of notes.